Welcome to this tutorial on the Pythagorean relationship. This is an introduction where I'll teach you the basic parts of a right triangle, and this is a right triangle right here. I'll get into that further shortly. And I also want to talk to you about how the relationship works and how we can use it. So let's begin. This is side A, or we call it leg A, and this is side B or leg B. And A and B are interchangeable. I could put A over here, and that'd be totally okay. And I could put B over here, and it'd be okay. They are interchangeable. This is side C, and this always is side C. Side C is always going to be across from the right angle. This little square denotes a right angle, and side C is always opposite from it. Side C is always the longest side, and we call side C the hypotenuse. D is pointing to that little box in the corner here. That little box tells us that this is a right triangle, and it tells us that that angle is 90 degrees. Let's just break that down further or review. A, or leg A, is one of the two shorter sides. Leg B is one of the two shorter sides. They're interchangeable, as I said. C is the hypotenuse. It's the longest side, and it's always opposite the right angle. And then D represents the 90-degree angle, which we call a right angle. Now I'd like to take some time to explore the Pythagorean relationship. What is it? Where does it come from? How does it work? We've already established that this is a right triangle. It has a 90-degree angle, and these are the sides A, B, and C. In order to understand the relationship and how it works, it is very helpful to take this same triangle and draw a square off of each side, as I've done here. And this is side A. And if this is side A and we draw a square, that means all these sides are the same because it's a square. They're all representing, this A represents some number. And to find the area of a square, we know that we do side times side. So in this case, we do A times A, and we get an area of A squared. And we do the same thing over here with B. If this is side B, that means it's a square, and all these sides are the same. It can be any number. And to find the area, we're going to do B times B, just like we did with A, and we get an area of B squared. And finally, we're going to do this with side C, the hypotenuse. If this is side C, that means all these sides are the same off of this square. And to find the area, we're going to do side times side, which is C times C, and we're going to get an area of C squared. So what does this have to do with the Pythagorean relationship? Well, what the Pythagoreans discovered is that if you take the area of square A and you add it to the area of square B, it always equals the area of square C if it's a right triangle. If this equation doesn't work out, it means you're not working with the right triangle. And they came up with this very famous, popular equation, A squared plus B squared equals C squared. I would like to show you one way in which this equation, or this relationship, A squared plus B squared equals C squared, can be used. So here I have a right triangle again, and I've drawn a square off of each side of the right triangle. Square A, or side A, has side lengths of 4 centimeters. So I want to find the area of square A. And to do that, I'm going to do 4 times 4, which is going to give me an area of 16 centimeters squared. And then I'm going to go down to square B, which is here, or side B. Side B has side lengths of 3 centimeters. So to figure out the area of square B, I'm going to do 3 times 3, and I'm going to get an area of 9 centimeters squared. Here's where this relationship comes into play, because over here in square C, you have no information. I don't have side lengths, I don't have the area. But if I go back to the equation, I can use this to find the area of square C. Because if I take the area of square A, which is 16, and I add it to the area of square B, which is 9, I can find the area of square C. And we know that 9 plus 16 is going to give me 25 centimeters squared. So this is the area of square C. And from here, I could find out the side lengths of square C as well, which I'll demonstrate in future tutorials. So I could find out all these side lengths as well. Finally, I'd like to show you one more way in which we can work with this. And this is the same idea. Here we have a right triangle. And this time, so here is a right triangle. And this time, you have 2 pieces of information. You have the area of square C, and you have the area of square B. We don't have the area of square A. So I'd like you to pause the tutorial briefly and see if you can figure this out. What would be this area right here?
So we got to think of this in a couple of different ways. One way to think of it is, what do I add to 39? What plus 39 makes 65? And that would be this area. Another way of thinking about that is we can subtract. I could take the area of square C, which is 65. Oops, got that backwards. So 65. And I'm going to subtract 39. 65 subtract 39 makes 36. So I could say the area of square A is 36 centimeters squared.